640 years ago, two space telescopes, the Hubble and the James Webb, along with ground-based observatories, are still periodically observing Betelgeuse, recording its brightness changes in recent years. It has been dimming and brightening constantly, showing that it is in the final stages of evolution. Inside this star is extremely unstable. Maybe in the near future, we will witness its explosion. The good news is, it is very far away from Earth, 640 light-years, enough to reduce its radiation intensity, and only visible light remains when it reaches Earth. If it was only 6.45 light-years away from Earth, the powerful radiation of the explosion could even melt the ice on Pluto, and all human exploration equipment would be destroyed in the storm of discharge. Life on Earth would be severely affected. In the history of the Earth, several small-scale extinctions have left traces in the geological layers. The characteristic radiation traces of supernova explosions have led biologists to believe that over the past billions of years, the Earth has actually been repeatedly swept by radiation from supernova explosions. Life has therefore evolved through many cycles, following the evolutionary model of stars. Massive stars like Betelgeuse will leave a white dwarf after exploding, while the remnant of the star will form a giant nebula. If this nebula is large enough, it may collapse again in the future and form a smaller star known as a second-generation star. Our solar system was also born from the remnant of a supernova explosion long ago, 4,600,000,000 years the Earth, and we are essentially fragments from these stars. We are intrinsically bound to the stars, and the universe is one of the most powerful energy release phenomena in the universe. Some scientists believe that in the future, we may use the energy from supernova explosions to make interstellar travel even simultaneously, detonate multiple stars to transmit information on a cosmic scale. Recently, astronomers have discovered an asteroid about 100 meters in diameter, called 2024 IR4, approaching the Earth and is expected to collide with the Earth in December. Music 2032. The most famous asteroid impact event in history is the Cretaceous extinction event 66 million years ago, when an asteroid about 10 kilometers in diameter hit the present-day Yucatan Peninsula of Mexico, causing a global catastrophe. The impact led to the extinction of species such as the sauropod dinosaurs, land-flying and marine reptiles, completely changed the Earth's ecosystem. However, this is not the only mass extinction event in the history of the Earth. The End-Permian mass extinction event, about 250 million years ago, was even more severe, when about 96 pH of marine species and 70 pH of terrestrial species disappeared. Although the cause of this event is still unclear, it is hypothesized that an asteroid impact could be one of the main factors. In theory, if the asteroid 2024 Y4 hits the Earth and falls into the ocean, it will create a tsunami hundreds of meters high, destroy coastal cities and infrastructure. If it hits land, it will cause major fires, earthquakes, and volcanic activity. Dust and ash from the impact will block out sunlight, causing global temperatures to plummet. Agriculture will collapse, famine will spread, and human civilization may fall into a state of prolonged chaos, even facing the risk of survival. However, after all, this is just one asteroid with a diameter of 100 meters. Its power is not enough to cause mass extinction, and currently, humanity is not without defense capabilities. Currently, scientists have proposed many solutions to deal with it, mainly destroy the asteroid or change its orbit. The first method has not been tested, but the test to deflect the asteroid orbit was successful in 2022. NASA, in the DART mission, has succeeded in using a 610 kg impactor, moving at a speed of 6.5 kilometers per second, to hit an asteroid, finally reduce the orbital period of the asteroid Dimorphos, 32 minutes, far beyond the initial prediction of 73 seconds. This result shows that even small changes in orbit can effectively prevent disaster. Of course, if the target is a giant asteroid with a diameter of tens of kilometers, like the asteroid that caused the extinction of the dinosaurs, then using the probe to collide will not be able to deflect its orbit. In that case, it may be necessary to soft land on the surface of the asteroid and place a nuclear bomb to destroy it. According to the classification of the level of cosmic civilization, in about 200 years, human civilization may master controlled thermonuclear technology, exploit all resources on Earth, build cities on moons, Mars, and in space. By then, the threat from asteroids will become insignificant. Currently, astronomers are focusing on strengthening the asteroid monitoring network to improve early warning capabilities. Just in the next few hundred years, no asteroid with a diameter of tens of kilometers or hundreds of kilometers hits the Earth. Then human civilization can become a multiplanetary species, greatly improving the ability to survive in the universe. Then we will leave the solar system and expand into the range of the galaxy, unless we encounter alien civilization. Human civilization has the ability to last tens of thousands of years, or even longer. In the early 1930s, astronomers saved about the supernova. They realized that a supernova can release as much energy as the sun releases in billions of years in just a few days. But they did not fully understand the principle behind this phenomenon. Scientists were looking for an explanation for how a star can explode and why a supernova releases such a huge amount of energy. However, no one could understand this phenomenon. At that time, two astronomers, Walter and Fritz Zwicky, came up with a groundbreaking idea based on the neutron, a newly discovered elementary particle. At that time, they suggested that a supernova is not simply an explosion, but the process of the core of a star collapsing completely on itself due to extremely strong gravity. The result of this process is a supernova explosion. After the supernova explodes, it will become an extremely small and extremely dense neutron star, the